Welcome, everyone. Welcome to this second session of our ongoing series of the journey of the industrial analog data. Really excited to have you guys back again, a lot of you back, and some of you joining us for the first time. Thank you so much for joining. It's going to be another good session, I hope, where you get to really get some insights from our speaker today. Just to recap, the first session, of course, of this series, the journey of the industrial analog data, was about data exchange. It is about how analog data at the source gets generated, created, and then moves up the value chain of the so-called ISO-95 pyramid, and more digital in nature, and enables so much more decision making as it moves along. So in the very same breath, or in the same extending the discussion forward, we look at the other aspect of the journey of this analog data, which is the transformation. So the once data gets generated and moves along the value chain, it transforms, and there's a purpose to it, right? Because it's got to serve some need at various levels of the ISO-95 pyramid. It could mean something to an operator, could mean something to the plant manager, could mean something to the CFO or the CTO, or the so on and so forth. So today, the second one, we focus on data transformation. And before that, let me just quickly introduce myself. My name is Anand Taparia. I take care of marketing here along with my team here at Utthunga, which means we have the profound responsibility to really to act as the bridge of the fantastic about 800, 850 people that we have inside the team, really coding away and developing state-of-the-art products and solutions for OEMs and industries worldwide to take that message out to the rest of the world, especially, of course, the industrial world. So really glad to bring the session here from the marketing team. And I'm also very happy and glad to introduce Chhatrapati, who is the speaker for today. Chhatrapati is the Director of Industrial Communications here at Utthunga, and also an OPC expert, represented us at Utthunga at the OPC Forum, the ODB, a regular trainer at the ODB Institute, with the ODB Consortium. So Chhatrapati, instead of me talking about it, I'll just let you introduce yourself a little bit.
Thank you, Anand. So I'm Chhatrapati. I have about 18 years of experience in the industry, and my primary focus has always been different communication protocols. And in the recent years, OPC and all the different communication protocols I've been focusing on. And I represent Utthunga at ODVA, OPC Foundation, and other consortiums. And my primary focus here is to build the specific protocol specific capabilities within Utthunga so that our customers can take advantage of those expertise and build their products.
Great. Yeah. Thank you, Chhatrapati. I think to have you be part of this session and take us along this journey, especially you were part of the earlier discussion also, and now to walk us through the transformation elements of the data. Looking forward to this session. Just on that note, this session today is going to be, so we're going to close in about less than an hour, 3 minutes. We've already moved 3 minutes further, so about an hour of this session. 45 to 50 minutes, we will engage in questions, where I have certain questions that I've sort of really prepared to get the insights from Chhatrapati to kind of do justice to this topic. We'll use the last 20 minutes, or rather the last 10 minutes or 15 minutes for questions from your side. So please do pass and share your questions through the LinkedIn window that you have access to. Fantastic. Well, before we dive in and I sort of start bombarding my questions to Chhatrapati, just to kind of create a mental alignment of what we're going to talk today, so to say, the agenda of today's discussion, we, of course, as I mentioned, going to talk about data transformation. Just the word transformation means it's going to change its meaning at different levels. So if you look at the ISO-95 pyramid here on your screen, from the field level up all the way to the management of the cloud, it's going to traverse and go through a journey, and it's going to transform. Say, for example, the temperature of a bearing of a motor at the field level could mean just a temperature, but to the SCADA, or the HMI, perhaps there'll be a calculation to say, okay, is it between my high and my low values, and then is this an alert or an alarm? And so something gets notified to the operator, and the same alerts, series of alerts, perhaps at the BI, or some analytics layer, could mean that, well, there are enough of these alerts happening, which means perhaps the motor is going to fail at some point, and the same thing could mean to something to another system there, saying okay, it's time for replacement or to raise a ticket, maintenance ticket or something. So while this transformation happens, a lot of other things also get converted and transformed. We of course spoke about the analog to digital transformation last time in terms of the data exchange, but there's also the physical layer itself transforming. So one of the things we're going to talk about today is the change of the physical layer, and part and parcel of that, and a lot of what we see is also the protocol changes. So the a data that's perhaps existing on a mod bus gets converted to perhaps some other protocol. So the protocol transformation is also. So we'll talk about those in the bigger context of the data transformation, and then we'll also dive into the other aspects of normalization and filtering. And it's important, given the deluge of data that we have, there is a need for normalization. So part and parcel, there's no point sending all the data. And of course, Satrapati will touch upon a lot of these things. And then we also wrap up finally with the touching on the topic of information model and the value, sort of modeling of data has in terms of interoperability. So with that alignment, let me dive into the set of questions. Satrapati, moving from the last discussion and now, and as I've sort of created the context for the people here, if you could help us understand what is the need of change of the physical layer. So why do we need, a physical layer change at all to happen?
So, Anand, the physical layer gets chosen based on the specific application that is being implemented at the field level. So, based on the application requirements, a specific set of devices that are supporting a specific set of protocols would be selected, and the protocols comes with their own specification on the physical layer. So exactly which physical layer they would support based on that. But that's what and that's where it actually ends. So and the field level devices produces a lot of data, and when and within a specific plant or within a specific control loop, the amount of data gets produced. And at the upper layers, the data that is produced by these control loops keeps accumulating, and that requires a completely different set of data exchange or data transportation capabilities. And to meet those requirements, definitely need to adopt a different technology, and that technology comes with its own physical layer specification. So, in this case, most of the upper layers use Ethernet or Wi-Fi, that kind of technologies where volumes of data can be transported. But in the field level, the requirements are completely different. Some have very stringent timing requirements, even though the amount of data is little. Some have doesn't have that kind of real-time kind of requirement. So it varies. So based on that application and based on the set of protocols those devices support to fulfill or to meet the requirements of an application, there'll be different physical layers. So from when you look at vertical data exchange or data transportation standpoint, it's the amount of data that needs to be transported drives to adopt a different physical layer at upper levels. And in some cases, within the field level itself, there is a change between physical layers based on the kind of despair systems that you are trying to integrate to have a horizontal integration.
Okay, okay, good. Are there any other motivations perhaps that you could think of, maybe to enable longer distances for the same data to travel? One medium physically may not necessarily support that, versus the other could, or any other motivations that lead to a physical layer change besides some of the reasons you mentioned.
So some of the existing physical layers stop at simply reading the data and writing the data back. But the more demanding needs in terms of security or in terms of having a parallel diagnostics monitoring applications or having any sensor based networks which doesn't overlap or doesn't uh, interfere with the process loops. So that pushes for more unified kind of physical layers, especially Ethernet-based physical layers. So that is again a strong motivation for majority of the industry and most of the industrial communication protocols to adapt and move towards Ethernet-based uh, physical layer. And some of the challenges are addressed by the APL, where the existing cabling and existing device networks can be taken advantage of without the need for a new cable or new infrastructure. Uh, so yeah, that's where it is.
Got it, got it. Sure, sure. Fantastic, great. And for some reason, even though this is a protocol or a physical layer, perhaps that's not so common. One thing that comes to my mind right now, for some reason, is Zigbee. It's a physical layer sort of that helps in self-organizing. The nodes, and really enables adding and deleting new nodes, or existing nodes much faster. So there could be so many different motivations, some that you've touched upon, and they're all governed by some of the needs that exist on the plant floor. Actually, the
Yes.
scenario. Good. So let's transition to the other part of the transformation, which is perhaps the more key part, really. Or at least that's how we tend to see, especially as we interact with so many customers across the world, so many manufacturing facilities, which is the change of the protocol itself, the communication language itself. So, Chhatrapati, again, same question literally. What is the need for a protocol change? Why do we even need protocols? Same thing to go over it, same data to kind of hop from one protocol bus to another one.
Yeah. So again, here the motivation is the application requirements, and they tend to change within the physical layer. I mean, within the field level itself, and of course across the layers. So at each layer, the demands and the requirements are completely different. So there are different protocols being adopted at different layers. So when we need to exchange the data between these layers or systems within the field level, uh, there is a need for transferring the data which is being gathered on a specific protocol to a different system that can consume that specific data. And in some of the cases, some of the industrial protocols recognize this need, and uh, they actually standardize how a specific protocol data can be encapsulated by uh, by the protocol itself. So, for example, if you look at Ethernet IP, it recognizes that there are several Modbus and HART-based devices. So it standardized how a HART device can communicate and still have the internal structure as per the HART protocol, but gets encapsulated by the Ethernet IP protocol. And same way it goes for Modbus as well. The advantage of standardizing this behavior is like there is a need in the market, and people tend to create their own way of mapping Modbus data to Ethernet IP or HART data to Ethernet IP, and that leads to more customized solutions which may not work uh, independently and freely. And so, to avoid any such interoperable issues, the standardization has been done for these two protocols to transport over Ethernet IP, and there are other similar examples as well.
Okay, okay. Well, that's very interesting. I mean, as a very strict conversion, I think most people will probably look at it as a conversion from protocol A to B. But the fact that one protocol could be a carrier of the next protocol, and without losing pretty much any nuances, is perhaps
Exactly. Yeah. Yeah.
so. And really speaking, protocol conversions just not exist. Just I mean, beyond a lot of the other reasons, given the heterogeneity of assets, software, hardware included, that we have on a typical plant floor from different vendors and whatnot. And if you really think about this, if you want to really realize the true potential of the IoT in terms of the interconnectedness of all these, I mean, protocols are needed, and the thing that plays the role there, of course, is the protocol converter itself. Now, it could be coming under various garbs and various names, but at the end of it, there is a black box literally that has something on one side and the out
Yeah.
protocol on the other side. So with that, Chhatrapati, if you could help us also understand, if with it being such a widespread use across the plant floor and shop floors, what are the characteristics that we should expect from a good, so to say, a good protocol converter?
Yeah. Yeah. Okay. So first thing, Anand, in the process industry, if you really look at it, so all the devices that are deployed, they come with very stringent process-specific requirements based on the kind of environment they are being deployed. For example, if you take any oil and gas kind of processing, right? So in terms of intrinsic safety, in terms of electrical specifications, they have very stringent, as well as physical environment requirement in terms of casing, what kind of weatherproof casing they should have to not to allow any dust or moisture, etc., to get into it. So any converters that you are deploying in this kind of environments must also meet all such requirements of the actual device, right? So this is one thing to look for. And in terms of the protocol conversion itself, so most of the converters, they are generic in nature. That means they don't bother exactly from which device they are gathering the data, right? So they would gather the data in a generic way and give on to the other side. So if the field device have some specific vendor specific features and special features, so or the data comes with additional uh, attributes that can add much value at upper layers. So these converters may be downgrading that information into a mere data point. So that is something to watch out for. If you are building something which is custom to your devices, so then it's a different thing. So you are well aware of the data model of your device, and you can expose everything without losing any quality of the data to the upper layers. So that is one thing to look for. And the third one is all the performance requirements. So performance requirements of the system should be met by these converters on both sides in terms of gathering the data from devices and again propagating the data uh, to the uplink as well.
Okay, okay. There's other aspect also with, if we talk about a small set of data points, perhaps it's not a big concern, but when we look at big process plants, refineries with thousands, millions of data points, and if we look at, say, for example, one protocol responsible for at least thousands of those, then the configuration part, is also a critical element. So any thoughts on?
Yes, yes. So the engineering becomes tedious when these converters are there. You would have to map everything, and there are some converters which may have some tools to do an automated mapping, but still someone needs to verify that to see if the mapping is as per the requirements of the overall system. And yeah, in most of the cases, it's just a very generic mapping that you get out of it. Like every variable will be named as like variable 1, 2, 3, and so on, and then they just get mapped. So that is, yeah, that makes it very costly in terms of engineering effort. In addition to that, there is again a security aspect of it. So most of the plants, they have their own complete device lifecycle process through which it goes through. So even if a device goes out to a service center even for a minor repair, when it comes back, it can't be trusted. So they have to do the entire verification and authentication of the device, starting from the hardware or any firmware has been tampered with. Uh, all such verification it has to go through. Now, with all these protocol converters, you can't leave them out of that scope. So these becomes again additional set of devices uh, which go through the same process, life cycle process for the device as well. So yeah, so my on this is to avoid this is uh, for any new devices that are getting deployed. Several devices nowadays comes with multiple protocol support, and especially ethernet based protocol support, and which can be expanded further for any new developments and technologies that are ethernet based, because the entire industry is trying to move towards ethernet based technologies. So if you are deploying such devices, then you are future proofing yourself to some extent without the need for protocol converters. And any future protocol upgrades can be provided by the vendors as a firmware upgrade to the device to support new protocols. They are becoming just like a checkbox on a data sheet. That's my view on that.
Yeah, that's interesting. I mean, if some of the people who probably belong to the protocol conversion industry, and including us, we play a lot of role for our legacy customer bases. Also, not necessarily a rosy business picture, but of course, that's the direction the industry would definitely want to move, and that's where it makes a lot of sense without having all this intermediaries in the between. There's one aspect you may have touched upon, Chhatrapati, but I just wondering if you can touch upon again, a little more, is the throughput part of the protocol converters. So sometimes that could also be an issue, perhaps.
Uh, yes, definitely, Anand. So again, when you are choosing a converter, it depends on your specific system throughput that you need at system level. And for these both sides, like the data acquisition or on the channel between the converter to the device, and as well as from the converter to the controller, on both sides the throughput requirements must meet as per the system requirements.
Okay, good. Finally, on this topic, of course, we've spoken sort of mostly in the context of the OT data, but the IC95 pyramid we see here, the OT IT integration, we of course would love to hear your thoughts on when we talk about protocol conversions, what does it mean for protocol conversions to the other side, to the IT side of the world?
Yeah,
If
yeah.
you, yeah.
So within the field level, when we are talking about protocol conversion, that is mainly just to establish a communication between disparate systems. But on the vertical side, when the data needs to travel through all the vertical layers, the protocol on each of these layers itself are completely different. Uh, and for that reason, they come with their own physical layer requirements, and in most of the cases uh, they are ethernet or wi-fi, and then the even mobile network based. So uh, the capability to move high volumes of data throughout the layers, that's what is the main motivation to have these high volume based physical layers and corresponding protocols. So the conversion happens from any of these lower levels to the upper level to get into that volume of the data. And uh, OPC is playing a big role in that area, even though it started in one of these layers in the ISA
Hmm.
pyramid. It has expanded itself in both directions uh, by creating the OPC PubSub specification, and by standardizing how to use MQTT and the MQP messaging protocols. It has expanded itself on how it can transfer the data towards the cloud through all the upper layers. And the same PubSub communication with UADP and raw Ethernet based, it allows the OPC to exist in control level and even in the field level. And the PubSub specification is further being utilized by the field level communication, which is OPC FX. So field data exchange, that's the uh, very latest part of the OPC specification, and the working group is still working on the specification to release it. So with these advancements in OPC technology, that OPC is spreading into both upper and lower layers.
So, it's sometimes when we hear, at least, when I talk to some of the people who are not necessarily so technically, involved, when we look at OPC UA, say, for example, and MQTT, they're definitely apples and oranges. Now, do we risk when we convert
Mhm.
missing out, or what are the perhaps the caution and the care to be taken when we convert from, say, for example, an OPC UA? It doesn't matter, all the way from the sensor through
Mhm.
OPC effects that you mentioned, and perhaps at the enterprise layer, or
Mhm.
just at the boundary, and then converts to MQTT to hit the cloud. Do we risk losing out something in that conversion? What needs to be taken care of?
Yeah, so this is again depends on how the entire system is deployed, configured, and what kind of tools are used, what kind of data conversions are used, what kind of data models are used, Anand. And in most of the cases, at each layer, somebody decides what is needed for that layer to operate, and what data it needs to propagate to the next layer. And during these decisions, it is very well possible for them to lose the quality of the data. So, for example, if a specific device sends a specific value and its units with a very high precision, right? And at the next layer, if the data is mapped to a tag or a specific data field which is having a much lower precision, so you will be losing the precision. And if not time stamped, then you will not have exactly what time that specific value has been read, or if you don't have a data which links that to a specific device, then you would not know from which device these values are coming in. Of course, the process control loop will continue to function, but whatever the data you are pushing out, uh, that won't be of much use. It just goes directly through all the layers up until the cloud, without any context. Simply data points are being pushed in millions and millions. So.
Yeah. Great. I mean, you use the right word for me to transition over to the next point that I really wanted to talk about, the context you mentioned, and,
Mhm.
and, and go into a little more depth of that. So, what we've covered physical layer change, we've covered protocol change as the part of the ability to convert, transform the data. And transform meaning, the value of the data at each layer for different applications. What I want to understand from you, is what do you think could be the barriers to getting insights from data as it moves along its journey?
Mhm.
Yeah, right.
Yeah. So uh, at each layer, when somebody is looking at the data, they are looking at it from a different perspective. They need something else when you compare it to a down layer or upper layer. So, for example, within the process control loop, uh, it is just a decision based on if the value is this, then based on that do something else. It's just the control loop and nothing more. So if we take an example of a flow meter, it may have current flow reading and flow rate, and as well as accumulated volume flow, and it is just that. So but when it goes to upper layers, somebody else may be looking at accumulated volumes with respect to how much raw material he needs to maintain, and at what rate the specific process control loop is consuming that specific raw material, and if it continues to consume at this rate for how many more days or for what duration, the process control loop can continue to function without shortage of the raw material. From that perspective, he may be looking. But for that, to make that decision, uh, when he looks at the accumulated volumes, he must know exactly from which device, from which process control loop, which device, uh, at what time those readings were taken, and over the period of time, like a time series data, how the values were changing. So he needs to have that full context, and during that time, what is the levels in the holding tanks, what is the reserve levels, and so on. So he needs to look at all this to get a clear picture of uh, the entire context and the current state of the system, right? So uh, without knowing that someone else would be doing this, if you simply propagating only the accumulated flow meter value, then that may not be of much use. So that's what the context brings into the picture.
So, so the context is the key that we keep hearing. And just once more, what is context? And more importantly, how challenging is it to really carry the context all the way through the journey? Because you
Yeah.
cannot lose the context.
Yeah. So the usual practice is different people are responsible for configuring, engineering, and deploying and maintaining different layers of the entire architecture. And unless they all are in unison on what kind of applications that are running in each layer and what kind of data that they would need to perform efficiently, and what kind of output needs to be added to the data that they have acquired before propagating to the next layer, so that these data points are becoming more and more rich information as they propagate through these layers, it is very difficult. So to achieve this, there are some standards and tools that are available, but how effectively they are being used, that's the important case. And in this also, again, one example is OPC. So in most of the cases, the OPC may be being used as a data transport mechanism rather than, despite all the very rich information modeling capabilities that OPC have. Uh, so even though the technology and tools are there, how you are using it also contributes to maintaining the context or not maintaining the context.
Okay. Maybe this is a tough question. I'm not sure if it's easy to answer, but who owns the responsibility uh, to really to be the
Yeah,
keeper?
so the best way to approach this is not to make too many decisions based on what you know at your layer, and you need to keep an open mind that all the different types of applications, all the time different types of analytics and requirements are uh, possible at the upper layers, and they may be looking for the information in a very rich format. So instead of taking decisions for them, you need to focus on how whatever the data that you have acquired, you can make enrich it with more information and provide it to the upper layer. So more information doesn't necessarily mean huge volumes of data. So uh, yeah, so you need to keep the essence even though you are reducing the volume, but still propagate it to the next layer by adding useful and contextual information back to the next layer. So as long as you do that, irrespective of which application or which new requirements that keeps adding at the upper layers, you may be uh, still able to meet those requirements.
Okay. Okay. Just to wrap up on this segment of our discussion, so we have data that gets generated, and and some of that gets stored in cloud and data lakes. A lot of that gets stored in process
Mhm.
historians. So we have all of this historical data, and then we have the real-time data also, and both. I mean, we need an analytics, not or the insights, not only out of the historical data, but we really need in real time also. And so, how do systems or processes enable real time decision making? Insightful decision.
So the data with all of its context and quality needs to be analyzed wherever it is possible. Like if the analytics capabilities are much closer to the edge, then those analytics should definitely produce something tactful. Some tactical actions they should produce, so that some things can be corrected immediately. And at the same time, they should propagate how frequently these tactful actions are being suggested and are being taken care to the upper level, so that more strategic plans can be applied based on how these things are happening. So I can take an example of a vibration sensor of a motor, right? So if there is a edge that can very quickly detect that, okay, uh, there is a disturbance in the vibration sensor data, okay, then it can immediately raise an alert or alarm based on which someone can check it. And if the range is even beyond certain values, then that can even lead to a pause of the operation and so on. So this is just tactical. Uh, but when these incidents are being propagated to the upper layers, okay, someone else can look at it and decide that, okay, in the past 3 months, this specific motors that belong to this specific vendor of this specific model number, okay, they have been causing these many number of incidents. And compared to a different vendor's motor or a different model number of the same vendor, it is much higher. Then they can take a strategic decision to replace these motors gradually, so that they don't get into this problem.
Got it. Got it. So let's move to some of the other, perhaps not as important, or perhaps equally important, but not as often talked about generally, parts of this whole data transformation journey. You know, given the amount of data, given
Mhm.
sensors are getting cheaper, compute power is so readily available, and everything. So there's no second thought to acquire it as about the data. But I mean, you've seen it a lot in your life, Chhatrapati, that does not make sense, that we really give all same importance to every single data point and whatnot. So then there comes the whole of the decision to
Mhm.
filtering and normalization. So I want to hear from you on that part of the deluge of data and what to do about it, rather than blindly just sending everything across to the cloud.
So, Anand, many of the early implementations of IIoT or early adopters of IIoT, and even to a large extent today, the data is simply being collected in volumes and being pushed into the cloud. Okay, so there is the key is to maintain the essence, reduce the volume of the data, and then present it in a more informative, information rich way to the next layer and to the next layer, so that by the time it reaches cloud, it is really information rich. The entire context is maintained, and any tactical or even strategic decisions can be taken, and it can produce actionable insights by any of these analytics programs. But when the data is being simply pushed onto the cloud from all these sensors, like if there is a uh, vibration sensor, right? So the frequency at which it gathers data at the field level must be maybe much higher, but you don't have to send the entire data to the cloud. So only a sampled or without losing the essence mm, concentrated data is good enough. Okay, at the edge level, it can consume the entire data and based on the basic edge analytics and based on some statistical algorithms, it can produce something more meaningful and without losing the actual essence of how the data is behaving or how the motor vibration is changing. Without losing that information, it can still produce meaningful data. So, uh, reducing volume but still maintaining the essence of the data is important.
Yeah, got it, got it. You mentioned Edge, and Edge perhaps has a key role to really act as the filter for a lot of these things. I actually wanted to kind of just extend that. Edge, of course, has a role to play to normalize. Perhaps to bucket the data, perhaps to aggregate the data, perhaps even remove duplicate data. So much things. There's another thing that ARC recently, I'm not sure when they introduced the term, the ARC forum, they call it thick edge. So
Mhm.
expanding the role of edge beyond that, but to perhaps also have compute and store. Just wanted to hear your thoughts on the thick edgeness attribute of edge.
So thick edges definitely uh, are in line with what I was just saying about reducing the volume but keeping the essence. But again, it depends on the specific software implementation that happens at the thick edge. They're more capable to run much more deeper analysis and they can sit at little higher level in hierarchy rather than compared to a standard or normal edges. So most of the edges are there just for the data collection and pushing, and some have very minimal capabilities like some statistical kind of processing they can do to reduce the volume a little bit. But thick edges can run deep analytics and provide a rich information to the upper layers and as well as the lower layers.
Okay. Wow. See, we've spoken about capturing data, moving data, storing data. On a typical plant, for there's so many devices, equipment, assets. Just if you look at even a motor, there's so many vendors that make the same kind of motor that could be existing right next to each other, on the floor. Now, with so much data, and everything that we spoke about till so far, there is needed a mechanism to really organize this data because given the variety of the ways the same data could be sort of be flowing through the chain, uh, you could easily lose context of what they stand for. And of course, that what I want to kind of get to is the whole point of information modeling, which perhaps is sort of already regarded as a key to really enable interoperability in the space of data connectivity and everything. So I wanted to hear your thoughts on data modeling generally as a topic, in this context we're discussing.
So most of the protocols they come with their own way of modeling the data, but in almost all of the cases that stops with the device, like how whatever the data that device can produce, how that data is modeled. Okay, but from there, if you are moving upwards, right? Uh, since it is not a single device or single vendor, there is no standardized way of representing these things. And that's where OPC comes into picture. And whenever I speak about OPC, I definitely say this thing. It is not just a transport mechanism. It is much more than that, and the information modeling is part of that. So uh, many of the protocols and the device vendors and the software vendors and tools vendors that provide different products that work in the entire industrial pyramid architecture, they realize the need for this specific standardized way of representing data, and that's where they are all collaboratively working with OPC Foundation to come up with standardized information models, which are mm, protocol specific, product specific, application specific, and so on. So, uh, for example, if you look at protocols for Profinet devices, for Sercos, for Ivolink, for many of these devices, there is a standardized information model on when you are reading the data from these devices and exposing via OPC, what should be the information model, right? But not all of the layers are interested in device level or protocol level information model. So at an upper level, there are some. There is again one more example I can take of is a packing machine. So for packing machine, there is an information model. For CNC machines, there is an information model. Uh, and similarly, different organizations, different standards that are there in terms of protocols, in terms of process, in terms of architecture. So they all are working in collaboration with foundation to standardize the information models, and a rich information model based on your specific requirement can have multiple information models. Like for example, if you are looking at a process plant, right, you can have the device specific protocol specific information models where you have all the device configuration and reading and data exchange capabilities. On top of that, if these are all process devices, then you can have a process automation device information model, which allows you to access the process data as well as diagnostics data in a very standard way, irrespective of which vendor, which protocol those underlying device support. So, like this, at each level, and based on the need and based on the kind of applications that run at this level, there are different information models. So, combining these information models to create a unified system from top to bottom is very much possible.
Okay,
And
okay,
with these information models, you can also layer different kinds of data transitions from bottom to top. So all the process variables can travel through a specific information model and specific channel, and there can be a different network uh, with different information models that are propagating all the diagnostic related informations and so forth.
okay. Just to conclude on that, I mean, not all protocols. You of course, I've heard you speak at the different forums, also different places, also about OpenC UA's information modeling capabilities. But we see heterogeneous protocols on a typical plant floor,
Mhm.
and not all protocols really support, and we may not yet know OPC UA FX and everything. We're still at the starting days, early days. So the protocols that exist there, not all of them support, is what I understand, an information model. So do we stand losing out on something if we do not have that currently?
Uh, Not necessarily, Anand. So, uh, irrespective of that, so there are some information models to which they can map to. So, for example, I was talking about PIDM. So, it doesn't matter what underlying protocol the process automation device supports, but when you gather the data and when you are exposing over OPC UA, they all represented as a PIDM information model. So you have a unified access to all the devices. So if you want to know what is this specific device, who is the vendor, there is a specific standardized node which you can read and know that okay, this is from this specific vendor. But if you don't have this, then the kind of mapping is completely custom. Everyone can map their own device to a different way, then that becomes a completely so in that case it just becomes a transport mechanism. There's no information model capabilities of OPC being used.
Got it, got it. Great, great. I think that's all the time. I think we said 50 minutes, 45 to 50. We are at the 3:50 in that time mark. So I think we should open it up to questions. Chhatrapati, get a few questions in the remaining time. So let me
Sure.
just hop onto this and get some questions here. All right, there are a few right now. The first one is, when you talk about protocol change, what does it mean for a safety protocol like ProfiSafe? Once the work is done, there may not be any need for further communication to layers above.
Yeah. So the the safety data itself may not have any significance at the upper layer, but definitely the diagnostics and the state of the system, all these type of variables will have some significance in the upper layers. So whatever is required that is being transported to the upper layer, that's where we need to consider all the different things that we have been discussing.
Right. Okay. The next question is, with respect to context, what does context mean for a very raw analog data like
Mhm.
level measurement, I guess? Do we
Yeah.
overcomplicate things by adding too much meta information?
Yeah. So if you are talking about level within the process control loop, then definitely you can say that it gets overcomplicated if you are adding all this. But that's not what we are talking about. When this level data or when this level measurement is being transported or transferred to the next layer or the next layer, so that's when the context needs to keep getting richer and richer, because at the device level, even the device itself doesn't have any context when it looks at that data. There can be a context of, with respect to its own state and whether it is in calibration mode or whether it is in actual measurement mode or whether it is in simulation mode. That kind of context is there, which is not relevant for the upper layers, but the context that needs to be built throughout the layers is different based on what upper layers are actually looking for.
Okay. I don't see any more questions at this point. So maybe if we get some more later on in the LinkedIn chat, we could answer some of those. But great, I think mm, we've pretty much at the end of this, Chhatrapati. We've covered the journey of the data moving, and transforming itself with sensors proliferating, with so much as we spoke about earlier, also the compute power being available readily, if not cheap, there's and data being easily sort of, you can easily traverse around. There's a possibility that we go crazy and sort of just send everything. But like what you cautioned earlier, in terms of the filtering, the normalization, and everything, there is some amount of choicefulness needed in terms of
Yeah.
acquiring or transporting all the data. And the last piece where you touched upon the data modeling, to me, actually, as we work with so many different kind of vendors, us as a service provider to OEMs across the globe, a lot of them, just sometimes even competing with each other, so many different protocols and proprietary and everything. What is really needed to really organize this data is the modeling part of the data, the information model, and it will really, I think, beyond the protocols like OPC or something else, the open protocols, but the information modeling part perhaps is really going to allow for interoperability also, and hence really help in data governance. Otherwise, all of this might really lead to
Yeah.
not much.
Yeah. Yeah.
So that's great. I see a few more questions. I'm not sure we have time, so I'll just ask this last one. And before I let you summarize a little bit, Chhatrapati, and then we can, close this session. The last one this just popped in was: are there any standardized information models?
Yeah, there are several standardized information models on it, and you can find them on the OPC Foundation. And VDMA also works very closely to generate different information models, mm, starting from a small digital scale to a very complex machinery. There are several information models that have been already standardized for the entire building automation. The entire backnet companion specification is there, uh, which is the information model for representing all the building automation related devices in the network. So the OPC information model capabilities, if correctly used, you can produce a digital system almost as close as possible to the actual system in the digital space to that extent. And most of the cloud infrastructure providers, they recognize the value of this, and Azure and AWS, they all started supporting OPC natively, and Azure to some extent even recognizes different information models as well.
Okay. All right. Good. Well, with that, I will give you the last word, Chhatrapati, to summarize it a little better, or anything else that we've not been able to cover that you think are relevant to this discussion. We have a few minutes, and then if you want to just close it for everybody here.
Yeah, so basically, the data needs to, when it is hopping through all these layers, it needs to become a rich and useful information, and that doesn't necessarily mean volume. First thing. Second thing is supporting a standardized information model at all layers makes things much easier. You don't have to uh, make a strong decisions based on which the other layers get affected. And since it is OPC and information model, standardized information models are used, the entire context of the pieces of data is maintained through all these layers up until the cloud infrastructure. So,
Okay, great. Well, thank you, Chhatrapati, for another insightful 1 hour that you spent with us and the audience on top of the session a couple of weeks ago. Thank
thank
you
you.
once again. And just to pull up, this was the second of the three-part that we wanted to cover, which is the data of the journey of the industrial analog data. There's a last of this series coming up in about 3 weeks from today, where again the journey of the industrial analog data and the application of data. So we what we're doing the last session, we'll have Chhatrapati and Jagjit also from the earlier session back, and we'll have a very fantastic discussion again, hopefully, where we'll pick up a few protocols, Ethercat, IO-Link, OPCUA, MQTT, Profinet IRT, and really understand their applications and use cases in the industrial world. So really bring it alive through some really actual scenarios of how these protocols get used in the industrial world in real world scenarios, and really kind of summarize a lot of things that we've discussed over the last 2 sessions. So please join us for this session. We'll of course post the joining links and everything on our LinkedIn channel. Do follow us on our LinkedIn channel. Just search for Utthunga on the LinkedIn search bar, and this video and all the other videos and fantastic discussions that we have with the members of the industrial consortiums and other thought leaders across the globe, and including inside Utthunga, they're all posted on our YouTube channel also. So just search for Utthunga on YouTube, and then you'll get all a rich library of videos also. Great. Well, thank you very much, everybody, once again for joining and spending your 1 hour with us. I hope, and we hope, Chhatrapati and myself and the entire team, that it was a good 1 hour spent. I look forward to seeing you guys again. Thank you so much.
Thank you. Thank you.